This video is about the number of copies of chromosomes and genes in each cell. Haploids have a single copy of each of their chromosomes and a single copy of each gene. Diploids have 2 copies of each chromosome and therefore 2 copies of each gene. So here's a haploid cell. I'm showing a chromosome and a second chromosome, and you can tell they're different because they have different genes, A and B versus C and D. So chromosomes 1 and 2 with 1n equals 2. In other words, 1 copy of each chromosome, and there are 2 chromosomes in total. A diploid with the same chromosomes would have 2 copies of each, and I'm showing big A, big B on one, little a, little b on another. That's chromosome 1. Chromosome 2, C and D, big C, big D, and little c, little d. That's chromosome 2. With 2 copies of each chromosomes, 2n equals 4. 2 copies of each, total of 4 chromosomes. What if I added a third chromosome to the haploid with genes E and F? That's chromosome 3. Now 1n is 3. If I added a third chromosome to the diploid, I'd need 2 copies of it, big E, big F, little e, little f. That's chromosome 3. And now 2n equals 6. We often care about where those chromosomes came from, so here is a diploid cell with 2n equals 4. In other words, 2 copies of each chromosome. And that came from parents, an egg and a sperm. And the egg was haploid, and I'm showing the squares are telling us it came from the egg. The ovals are telling us that chromosome came from the sperm, from the father. And so the square, big A, big B, came from the mother, the female parent, and the little a, little b came from the male parent, and same big C from the female, from the male parent. The 2 gametes are each 1n equals 2, they are haploid, but they have fused into a diploid offspring with 2n equals 4.